All right, so chapter 12, climate change. Now, of course, we take something as a topic as complex as climate change and try to condense it down to one chapter, let alone one lecture. We're going to be leaving a lot of stuff out. Now, there are three main goals that I would like to achieve with this chapter. That is one, is I want to get everybody up to speed on some basic understanding of climate change with focus on some physical properties of greenhouse gas, which will be important for policy analysis in the next chapter. Second, we'll talk about some cause and effect of climate change. And third, we will focus on the IPCC report and its findings. Right? And IPCC, it is considered the gold standard of climate change science. Right. Now, there are hundreds of videos about climate change, but I found this one here that when you get a chance, take a look, that greatly summarizes the issue with climate change, the challenge ahead. But basically, we have emitted greenhouse gas. This greenhouse gas concentration in the atmosphere traps heat coming from the sun, and that is having the climate impact that we are observing today. Now, with greenhouse gas, our focus is going to be on carbon dioxide because by volume, carbon dioxide is the primary greenhouse gas. And so the EPA here has a very handy index. Right? It's called the global warming potential. If you want to know more about it, go ahead and click the link here. But basically, with the global warming potential, we can look at carbon dioxide as the unit. So carbon dioxide as a unit of 1, and that way we can compare all other greenhouse gas with using a carbon dioxide. And so if we look at methane, for example, right, methane has 25 times more global warming potential compared to carbon dioxide, nitrous oxide, 298, and fluorinated gases, we're looking at tens of thousands. Now, fortunately, by volume, these other greenhouse gas are really small compared to carbon dioxide. And so when you look at a graph like this, what is typically, or almost always, that is converted to CO2 equivalent, so that we can see, so that we can actually observe the impact of these greenhouse gas. Now, one of the most important physical characteristics that we are concerned with from a policy perspective is the concentration, is the lifetime in the atmosphere of these various greenhouse gas. And you can see here that when we talk about greenhouse gas concentration, we're talking about in time span of in hundreds of years. Right. Now, why is this important? Well, so let's take a look at these two illustrations here. This top graph, this really should say annual emission, not concentration. I think the book made a mistake here. So go ahead and cross that out and write annual emission. But basically, every society can be broken down into these 4 different stages. So as the society begin to develop, they will be at an increasing emission. So that means pollution is increasing, or carbon emission is increasing, and every year after year, the amount polluted is increasing as well. And then next period will be considered the emissions freeze. So now emissions freeze does not mean that that does not mean the society stop polluting. What it does mean is that we're no longer increasing the amount that we are emitting every year. And finally, when we get to emissions reduction, again, we're not actually reducing the amount of the emission in the atmosphere, but what we're doing is reducing the amount that we are polluting every year after year. Finally, it's not until we get to zero emission where, well, we have no more carbon emission from our society. Now, so this is what the policy, climate change policy, or any emission policy have control over, is we can control how much we produce on an annual basis. What we don't have control, and what really is causing the impact, is the concentration. So down here, we're going to see that in the first period, right, the concentration of greenhouse gas is increasing, but it's increasing at an increasing rate, and we can tell that, we can notice that by the curvature of the curve, and the fact that it is increasing the annual emission. Even in the emissions freeze period, where emission is no longer increasing, however, the concentration, right, is still increasing, even though although it's increasing at a decreasing rate, right? And finally, we're at emission reduction, but the concentration again is still increasing. Right? It's not until we get to almost zero emission here that the overall concentration of greenhouse gas in the atmosphere will start to decrease. Right? And so this illustrates here a difficulty, and that we'll dig deeper into in chapter 13 about how much of it, what kind of policy would be suitable when we're dealing with when dealing with this scenario here.